I remember back in the 10th grade in math class, there was this brain teaser that the teacher posed to us, and it's funny because today the answer is so obvious, but at the time it was hotly debated, and I'll share it with you here so that you can share the laughing that I have over this question, and then I'll apply it to some modern things, by the way. The question was, is the number of grains of sand on the planet finite or infinite? It seems obvious, right, that it can't be infinite. If so, then the beaches would be larger than the entire universe and beyond, right? Because infinite has no limit. So obviously the number of grains of sand at any given moment on Earth is finite because the Earth itself is bounded by finite geography. It's a sphere of a given size. Yeah, sorry, all you flat earthers out there. The Earth is not flat. It is a sphere, and it is a finite sphere. So that means the number of grains of sand is finite. And yet I remember other people in class arguing with me. Yeah, even back in the 10th grade, I would get into arguments with people about things. I'm like, are you stupid? It's so obvious that the number of grains of sand is finite. Why are you even arguing this? They would say, no, it's infinite. It could be any number. The minute you start counting, there's more. Like, okay, you're not making any sense. It's not infinite. Just because you can't count them doesn't mean it's infinite. You know, at any given moment, it's finite. Obvious for the reasons I just mentioned. I mean, obviously, if it were infinite, it would be larger than the planet because the planet is finite. So the Earth isn't one giant sandbox. So that's just one simple example. In any case, you still have people today that are arguing that the oil underground is also infinite. Now, these people have a little more sophisticated argument, which is that the oil is being replenished in a very rapid timeline. These people, they reject the theory of fossil fuels. They say it's not fossil. They say it's not millions of years in the making, that it can be produced from within the Earth in decades, not millions of years. Now, I'm not an expert on that theory, and so I can't really dismiss it unless I study it. I do know that it goes against everything that we've been taught about geology and fossil fuels and so on. But hey, sometimes we've all been lied to by the status quo for many, many years. So I'm just going to say I'm open to hearing the evidence, but it sounds a little crazy. However, who knows? Who knows? Maybe, I'm open to evidence. That's all I'm saying. I'm open to evidence that could change my mind on the issue. But even then, it must be true that the amount of fossil fuel that's in the Earth at any given time is finite. If it were infinite in a snapshot, then there would be more oil than the entire planet itself. In fact, the oil would fill the solar system and the universe and the cosmos. Like from the Big Bang, everything would be oil if it were infinite. And it obviously isn't. So the amount of oil inside the Earth at any given moment is finite. Now, if it's finite, that means that we can obviously run out of it, even if you believe that it can be recreated rapidly. If our use or consumption of this resource is more rapid than the replenishing timeline, then obviously we can run out of it. So getting away from the oil economy is obviously a very important long-term goal. Now, I approach this from a rational point of view of sustainability, not from a climate change, global warming, CO2 is evil point of view, because CO2 is not evil. CO2, carbon dioxide, is a gift to our planet. It is nutrition and food for plants. CO2 is what makes plants grow. It's what makes plants produce food. It's the reforestation miracle molecule for our world. I wish we had more CO2. We're barely above 400 parts per million in the atmosphere right now, which is hardly any CO2. I wish we had 500 parts per million or more. Then we'd have a lush, a wetter, more lush planet where you could grow more food more easily. The deserts would be turned into rainforests. Earth used to be more lush. You know that, right? Used to be a lot more. When CO2 was higher in the past, it has been more than 10 times higher. We've had CO2 in the past that's been over 5,000 parts per million. And the planet was more lush, more green. So if you're opposed to CO2, it's like you hate plants or something, because CO2 is the molecule for plants. In any case, my point on fuels is that we have to shift to a nuclear fusion system of energy creation, which converts mass into energy, using the E equals mc squared ratio, by using matter that's held in place by very powerful magnetic fields to turn matter into energy through fusion reactors. So this kind of reaction, of course, would make electricity very affordable and very, very clean in our world. And it doesn't have the risk of let's say a Fukushima or Chernobyl meltdown. That's old school nuclear power that uses fuel rods and so on. The new fusion reactors that are being worked on by many companies, by the way, there's like 4 or 5 companies working on these, including one company that is a weapons manufacturer working on this as a portable power center for the military, by the way. These don't explode. If something goes wrong, they just lose power and fail to generate electricity. They don't use nuclear fuel rods. They don't have radioactive isotopes produced, such as cesium-137, or they don't use uranium-235 or plutonium-239, or produce iodine-131 or strontium, what would that be, 91, or any of that stuff. They just take basically heavy water, I believe, is what they use as a mass source, and then they bombard the mass with a tremendous amount of energy to cause that mass to produce more energy than it takes in. And then that extra energy, which is sometimes called over-unity energy, is then converted into usable electricity. It's a fusion reactor system. And Lockheed Martin, by the way, is the company that the weapons manufacturer that has already actually developed one of these systems that they've demonstrated. So it's out there, it just needs to be scaled up, and they need a little better refinement of the technology to have greater efficiency of power consumed versus power produced. Now, getting away from the oil economy, though, means that we have to have all the systems that currently burn fossil fuels use electricity instead. And that's not such an easy thing. The technology does not exist yet to turn, let's say, airplanes into electric airplanes for long flights, like across the Atlantic Ocean, or to turn tractors and agricultural equipment into battery-powered equipment. We don't have the battery technology to do that. Or the long-haul trucking that is very prominent in the United States, which, trucks deliver everything. The semi-trailer, tractor-trailer rigs on the highway deliver your food, your parts, your medical supplies, pharmaceuticals, fuel. Everything to keep everything running is delivered by truck. And those trucks can't run on batteries because there isn't battery technology with a high enough energy storage density to be able to do that. So even if you have fusion reactors that can generate cheap electricity, you still can't, you can't have tractor trailer rigs running down the highway rolling extension cords behind them that are plugged into a reactor 50 miles back. Doesn't work that way. So unless you have battery technology on the rigs, you're not going to be able to use them. You're not going to be able to run them on electricity. So you're still going to need fossil fuels until we have a breakthrough in battery technology, even if we already have a breakthrough in hot fusion energy creation technology. Does that make sense? Battery technology is the limit. We don't have good storage. And no, Elon Musk is not going to solve this problem either. That guy is a hype artist. He makes all these silly promises. Oh, we're going to dig holes under Los Angeles. Really? Really? Prove it, buddy. I mean, Elon Musk is a hype artist. He just makes up all this fleeting nonsense. Oh, we're gonna send and put a colony on Mars next year. Oh, really? Oh, remember that time he announced that he had like an underground. He had a transportation system that he was going to start building between, I think, New York and Boston and Washington, D.C. or something. And none of those cities had ever heard of his plans, and they'd never approved his plans or anything. He was like, he just started tweeting, yeah, we got approval. We're moving ahead. And the city planners were like, what are you talking about, dude? Anyway, Elon Musk is a hype artist, and his batteries are not that great. I'm just telling you, his batteries are not that great. He makes these batteries for the Tesla cars, and which, by the way, they still can't manufacture correctly. And Tesla will probably crater at some point. It will collapse as a company, I'm pretty sure, because they don't know how to make cars. But all they know how to do is take people's money without delivering a car, which is a really crappy business model, frankly. It doesn't last very long. So unless Elon Musk is visited by aliens who hand him like alien battery technology from planet Zorg or something, remember, let's call it Planet Musk. maybe he's going to be handed alien battery technology from Planet Musk. Then his cars would be workable and the company would be viable, and he could make trucks with alien Musk technology or something. But that's unlikely to happen, right? Because there is no Planet Zorg or Planet Musk. There is no alien visitation to his factory to teach him how to make better batteries. All he's got is lithium ion, which, by the way, explodes sometimes, catches on fire, generates too much heat, and uses limited trace elements, by the way, which are harder and harder to get because they're mined out of China. So these elements, which is not just lithium, but other elements that are used in these batteries, come out of places like China, or sometimes the Congo, or places in Africa that are, economic and political disaster zones where you have to get these minerals mined out of the ground using basically blood slave labor to get these minerals to make your super green, solar system or wind power system, or your Elon Musk mobile that you want to think is all super green and clean. Hey, a bunch of slaves mined that stuff who are being whipped and chained up in Africa somewhere. Don't you know? Don't you know where these elements come from? Follow the supply chain, people. A lot of these elements like gallium and a lot of these elements, these rare earths, as they're called, rare earth elements, come from places where there's like child labor or slave labor practically, human rights abuses like crazy. And then all these people in America talk about how their products are so green and clean and ecologically sound. Yeah, you ever look at what went into your product? How many people died, to create that mine over in Africa to give you your minerals that you need? I mean, what's the one that they're running short on right now? I forgot the name of it. It's like thallium or something that they're running short on, but they seem to have an excess of delirium. They've got plenty of delirium over there at the Elon Musk factory. If only they could make batteries out of delirium, then they would have an awesome revenue model. But hey, the crypto coin community has managed to generate billions of dollars in valuation out of delirium. They have a whole ICO for delirium crystals, and people buy into it because it has the word blockchain on it. So you talk about hype. It's not just Elon Musk. It's also the delirium blockchain companies that are getting sky-high valuations while offering nothing that's real, which is kind of the Elon Musk business model. In any case, criticism aside, we do need to get off of the fossil fuel economy. In my view, it's just going to take a lot of breakthroughs in hot fusion, power generation, plus increased battery density technology, and neither one of those exist yet. And along the way, by the way, we're going to have some really awesome chemists figuring out how to build these systems without using the rare earth elements that are in short supply right now, such as gallium, for example. There are a lot of elements that are used in these products which are running out of supply. Yep. So, you can't make these elements. You can't make them. You got to mine them. You know that, right? You can't just make an element like you can't make gold. If you could make elements, you would just run gold all day long and you wouldn't build cars. You just generate gold all day, or platinum or something like that, and just cash in on that. So you can't make elements. You got to mine them out of the earth, or long term, you got to lasso an asteroid that's full of elements and somehow land it on the planet without, crashing it into the ocean and creating a 2-mile-high tidal wave that wipes out coastal cities. If you could mine asteroids, you could get more elements from the asteroids. But, barring that option, all we have is here on Earth, and it's a limited supply. And yes, as I opened the segment with, it is finite. There's only so much gold in the ground. There's only so much iridium in the ground. There's only so much gallium in the ground, and so on. That's it. Whatever's there is there. The Earth isn't making elements. I hope you know that. Like how the Earth makes fossil fuels over time, because those are long-chain hydrocarbons. They can be manufactured through geologic processes, but you can't make elements. Maybe I should go into a whole science lesson on this. Fossil fuels are long carbon chains, mostly carbon and hydrogen, just long chains of complex molecules, hydrocarbons. And as long as you have carbon and hydrogen available, which is everywhere, then you can make fossil fuels. But you can't make iridium. It's an element. You can't make, pick one, magnesium, copper, zinc, nickel. You can't make these things. They're elements. Whatever you have is what you have. That's it. There's no more. The only way you make them is to explode stars. I mean, when stars explode, then you can make elements. That's how the heavier elements were created, like lead. Lead is a result of exploding stars. That's how we have lead. That's where lead comes from. It's a heavy element. It's like atomic mass units 206, 207, and 208. Like aluminum is only 27. Aluminum is very light. Aluminum came earlier in the cosmos than lead, most likely, because it takes many sequences of exploding stars to add mass to elements to achieve what are called the higher mass stable isotopes that are non-radioactive and don't break down and lose mass over time. So lead 206, for example, is a stable isotope. It stays lead 206. Whereas, let's say like cesium-137 is radioactive. It loses its radioactivity and it drops down to cesium, I don't recall the cesium map, but I know cesium-134 is radioactive and then 133 is stable. So through losing mass, cesium-137 eventually drops down to cesium-133. But I don't know if it jumps to 135 first, and that's a short half-life or what. Yeah, every element's different. It's based on the laws of physics. You got to look at the map. But eventually it drops down to cesium-133, which is stable. But cesium-133, where does that come from? Well, usually exploding stars. Again, that's how you get this stuff. You start out in the universe, in the Big Bang, you start out with like helium and hydrogen, just super, super light elements. And from there, you have to form the heavier elements over time through fusion processes. Anyway, I'm not going to go into all that right now. I guess that's like high school physics or whatever. But we do have to get off the fossil fuel habit. And we have to get away from relying on these rare earth minerals because they are a finite supply. That's the conclusion here. Is what I was trying to say is that there are things that we're using today that are a finite supply. It's finite. There aren't unlimited numbers of grains of sand on beaches. There isn't an unlimited amount of fossil fuels, and there aren't unlimited quantities of rare earth elements. All of these are finite, and since we're consuming them, we're going to use them up. So we better plan ahead and find alternatives before we run out, as a civilization. So maybe everything I just said is obvious. I don't know. But it's worth covering. So thank you for listening. Mike Adams here, the Health Ranger. You can hear more of my podcasts at healthrangerreport.com.
Learn more at healthrangerreport.com.
Thank you for watching. If you want to support our mission, visit us at healthrangerstore.com for the world's largest selection of lab-verified superfood and nutritional products for healthy living. It's at healthrangerstore.com.